Good afternoon, friends. Today we are having a very useful lecture on complex analysis, and in our studio we have Professor Ravi Borana with us. He is going to deliver this very important and useful lecture for third year BSc students. I request him to give his talk on this very important topic of analysis, namely complex analysis, and in detail he will talk about analytical functions, harmonic functions, and harmonic conjugate, etc. And also will discuss some of the images of some curves in complex planes under the some bilinear transformations. So I request again Professor Ravi Borana to.
Thank you, sir.
Yes.
First slide.
Okay.
Yes. We shall be talking about analytic properties of complex functions. First slide. Yes, let's start with, this is the topic which is there in the third year BSc paper 8, analysis 2, unit 5. And about the complex variables and complex field, the set of complex numbers, already all the students have studied in the 11th and some applications in for second year. Now let's see about the harmonic function. We start with the definition of harmonic function. That x1, x2, xn are the real variables. U is a function having these n variables defined on a domain D. If the first and second order continuous derivatives, partial derivatives of u exist, and the equation, the partial differential equation del square u by del x1 square plus del square u by del x2 square plus dot 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 plus del square u by del xn square equals 0 satisfies, then u is called harmonic function. And the expression, next slide, we write in this in a sigma symbol, is also known as Laplace's equation. Next. Yes, so before we talk about uxy and u square xy both are harmonic, then u is constant. Let's see some application of that, the harmonic function. Please look at this, del u by del x we shall represent by ux, del u by del y we shall represent by uy, and del square u by del x square by uxx, and like that. Now uxy is harmonic, that means uxx plus uyy is 0. It is same as del square u by del x square plus del square u by del y square is 0. Okay. Now let's have one example of harmonic function, that is this function w is z square I have. Let's take this w is z square, that is fz, z is x plus iy, so it's a simplified form is x square minus y square plus i2xy. We shall write it is uxy plus ivxy. So u is the real part of z square that we all know, real part of z square, and v is imaginary part of z square. So real and imaginary part of z square are harmonic. Let's see how this is. U is x square minus y square. It is a real part of z square, and we claim it is harmonic. Let's find the first partial derivative of u with respect to x, that is 2x minus y square. Y is constant with respect to x, so it is 0. Then uxx, again differentiating partially with respect to x, this we get 2. Okay, derivative of 2x is 2. At the same time, uy is minus 2y, x square being constant, its derivative is 0. Minus y square, derivative minus 2y. Then uyy is minus 2 with respect to, and we can see 2 plus minus 2 is 0. So real part of z square is harmonic. Okay, and same way imaginary part is harmonic. Real part of e raised to z, for example, e raised to z. What is the real part of e raised to z? That is x plus iy. We put e raised to x into e raised to iy. Now using this Euler's formula, we have e raised to x into cos y plus I sin y. So this is e raised to x cos y plus I e raised to x sin y. Now throughout this we write u plus iv. When I write u, we mean uxy, v is also vxy. You can see that real and imaginary parts are harmonic. That can be easily verified. Now again, sir, we come back to that slide, u and u square. Yes, u and u square both are harmonic functions, then u is constant. See, u is harmonic, so we have this part uxx plus uyy is 0. Please keep in mind, because u is harmonic. Now u square is harmonic, so we have to, we need to see this part, u square xx plus u square yy is 0. U square is harmonic, so this is given. Now u square x, what is the u square x is del by del x of u square. U is a function of two variables x and y, so it is going to be 2u into derivative of u with respect to x, so ux. Alright, and then u square xx derivative of this quantity with respect to x, so it is 2u into uxx plus 2ux into derivative of u, that is ux. Alright, so let us come back to this. U square xx is this. Similarly, u square yy is 2u into uyy plus 2uy square. Now I take permission to write this ux square. Friends, u square is harmonic, so u square xx plus u square yy is 0. This addition will give us 2u into uxx plus uyy. Yes, addition of these two. Now I am adding and I am just getting back to this. U square xx plus u square yy is 0. Okay. Now what is next? Plus 2 times ux square plus uy square is 0. Okay. Now first equation, u is harmonic, so uxx plus uyy is 0. So this part becomes 0. Now this is what is left is ux square. Sorry, better way we write this way to avoid confusion. Ux square plus uy square is 0. Now friends, ux square plus uy square is 0. This are both are real quantities. Sum of the squares of two real numbers is 0, so each one is 0. So it gives us ux square is 0 and uy square is 0. This gives, okay. Sum of the squares is 0 means each square is 0. Now the square a square is 0 means a is 0, so ux is 0 and uy is 0. U square is 0, uy is 0. Now as I have mentioned, u is a function of two variables, u, x, y. Ux is du by dx, derivative with respect to x is 0, derivative with respect to y is 0. That means u is independent of both the variables, hence u is constant, and we are proved. Next slide. Yes, this is the definition of analytic function. A complex valued function f d to c. D is a domain in a complex system or complex field C. Then f is analytic at z0 if f is differentiable at every point in some neighborhood of z0. Next slide. Yes, if fz equals uxy plus ivxy is analytic in D, then component functions u and v are harmonic. That also can be seen. So analytic function, we use the analyticity of the function f, then the CR equations are verified, and then partially differentiating u and v, we get both u and v are harmonic. Next slide. Okay. fz is uxy plus ivxy is analytic on D if and only if CR equations du by dx equals dv by dx dy and du by dy is minus dv by dx are verified. Next slide. Okay. So this should be stated here that fz equals u plus iv, it means uxy plus ivxy is analytic in D. Yes, if and only if ux is vy and uy is minus vx. Okay. The slide, the previous slide. Yes. uxy is harmonic and vxy is a real valued function such that fz equal to u plus iv is analytic, then v is called the harmonic conjugate of u. So friends, it means if v is a harmonic conjugate of uxy, then we have fz equals u plus iv is analytic. That means u and v satisfy CR equations. These are CR equations, Cauchy-Riemann partial differential equations. Okay. Next slide. If u is a self-harmonic conjugate, that means u is a harmonic conjugate of itself, then u is constant. That can be seen very easily from here. That just few minutes ago I said fz equal to u plus iv is analytic, then this CR equations verified. V is a harmonic conjugate of u, then fz is analytic. Okay, we know this part. Let's see. If V is harmonic conjugate of u, then fz equal to u plus iv is analytic, and therefore CR equations ux equal to vy and uy equal to minus vx are verified. Here what is given? Slide please. U is a self-harmonic conjugate, so u is a harmonic conjugate of itself. We write v is a harmonic conjugate of u, so in this particular case we have u equals v, v equals u. So we shall substitute here that part, v equals u in first. So we shall be getting ux is what? V is u, so uy. From the first equation please, first and second. This is uy equals minus vx, so minus ux. Make sure that v is a harmonic conjugate of u. We are given that u is a harmonic conjugate of u, so v equals u. Friends, just combine these two expressions, what we get. Substitute the value of uy here. Ux is minus ux, so 2ux is 0. We get ux equals 0. And substituting value of ux in any of these two equations, we get uy is 0. So ux, and just we have seen that ux and uy are 0. U is a function of two variables x and y. That means u is independent of x and y both. So u is constant. This result is proved that if uxy,
Next.
Yes, next.
Slide please.
U is a harmonic conjugate of V and V is a harmonic conjugate of U, then both U and V are constant. So in the same process we can see that. Let's see this result. We start with V is a harmonic conjugate of U. So we have this CR equations, Ux equal to Vy and Uy equal to minus Vx. Again what we have, U is a harmonic conjugate of V. So U is a harmonic conjugate of V, so V plus IU is analytic. V plus IU is analytic, so by CR equations, analytic functions, so the component functions satisfy CR equations. What we have? Yes, Vx is Uy, number 3, and this is Uy is, yes, this is Vy is minus Ux, number 4. Friends, look at 1 and 4. 1 and 4 gives what? Look at this 1 and 4. Ux equals Vy, but Vy equals minus Ux. So again the same arguments, just few moments ago we have given this is 0. So Ux is 0. and we will get ui is also 0 by repeating same arguments that you compare 2 and 3, immediately you will get ui is 0, so u is constant, and ux is 0, ui is 0, so substituting vx is 0 and vy is 0, so v is also constant. Okay, next slide. Okay, v is harmonic conjugate of u and w is harmonic conjugate of v. Then u plus w is constant. Look at that, v is harmonic conjugate of u, our first line is there. W is harmonic conjugate of v. So we write this, instead of u we write w. Here you put w. v plus iw. Wherever you just replace it by w and use the same terminology. This is, so from 1 and 4, just pay attention please. Just from 1 and 4, ux equals vy, but vy equals minus wx. So this will be minus wx. Now you can see that this becomes ux plus wx is 0. It is same as u plus w. Del by del x of u plus w is 0. And using 2 and 3, we can see that d by dy of u plus w is 0. So if v is harmonic conjugate of u and w is harmonic conjugate of v, then u plus w is constant. Next slide. Okay. Function, analytic function, fz is u plus iv, alpha, beta, gamma are complex constant, and one important note that alpha, beta, gamma all are not 0. Alpha, beta, gamma all are not 0 at a time. Then slide. The same slide please. Yes. Fz equal to u plus iv is analytic, so we have ux equal to vy, uy equal to minus vx. Slide, the same slide please. Yes, alpha, beta, gamma are constants, all are not 0, and alpha u plus beta v. Alpha u plus beta v is gamma. Then f is constant.